This is section 3.1, Graphing Linear Equations, part 1. We're going to have 3 different parts to this, but today is part 1. A linear equation is an equation that forms a line when it is graphed. So the word line is in linear, so it makes a straight line. Linear equations are in the form of ax plus by equals c, which is called standard form. The ax and the by are called the variable terms because they have the variable x and they have the variable y. C is called a constant because it does not have a variable. Here's an example of a linear equation in standard form. It is in the form of ax plus by is equal to c, where a is 3, it's the coefficient in front of x, b is 2, which is the coefficient in front of y, and c is your constant. Example 1, determine whether each equation is a linear equation. Write the equation in standard form, identify a, b, and c. So if it is in this form, ax plus by is equal to c, or if you can make it to look like this, then it is a linear equation. For example, you cannot have an exponent. You cannot, either x or y cannot have an exponent. X cannot be in the denominator, or y cannot be in the denominator. All of those would not be in this form of ax plus by is equal to c. Let's look at example A. Y equals 4 minus 3x. Well, if we need to move the 3x, the negative 3x on the other side. So what we would have to do is add 3x to both sides. Now we cannot combine those because they have different variables. So that's 3x plus 1y is equal to 4. Now that is in the form of ax plus by equals c. So yes, it is a linear equation where a is 3, b is 1, and c is 4. Example B, 6x minus xy is equal to 4. Look at that closely. Is that in the form of ax plus by is equal to c? Well, the only thing is the negative xy. It has to be just a y, no x. So no, it is not a linear equation. Example C, y equals negative 1. Well, again, is it in this form? What's missing? The x. Could we say 0x plus, that's a 1y, is equal to negative 1? Then it is in the form of ax plus by equals c, where a is 0, b is 1, and c is negative 1. So we were able to manipulate that equation to get it in the form of ax plus by equals c. Example D, y equals x squared minus 4. That is not in a linear equation because of the x squared. Okay, same directions. Example E, is 1 over x plus y equals 3. Is that a linear equation? And it is not. Again, standard form. You have to memorize this, so you might need to write that several times. And because the x is in the denominator, it would not make it a linear equation. So the answer is no because of the 1 over x. Okay, let's look at example F. 6x equals 3y minus 8y. Well, could we combine those and get 6x minus 5y, or excuse me, 6x equals a negative 5y? Okay, now again, is it in the form of ax plus by? We need to move the 5y, the negative 5y, on the other side. So to move it, we would have to do the opposite, which is adding 5y. And again, put it in standard form. That would be 6x plus 5y is equal to, everything went away over there, so you'd have to put 0. So now it is in the form of ax plus by. A is 6, B is 5, and C is 0. Example G, now in this particular problem we have M and N instead of X and Y. So anytime you have different variables, you do it alphabetically. What comes first in the alphabet? M. So it would be AM plus BN is equal to C. So that would be the standard form. So in this case, we would need to add the 4M to get it over with the negative 5M. So that's 2N minus M is equal to 5. Now, again, we have to get it where the M is first. That would be standard form. So I'm going to rewrite it to say negative M plus 2N is equal to 5. Now, technically, A is always supposed to have a coefficient of a positive number. And right there, it is a negative 1. So we would need to divide everything by a negative. The shortcut for dividing everything by a negative is it changes the sign. So that is the true standard form, where A, the coefficient in front of X, or in this case, the coefficient in front of M is a positive number. H, we need to get the 3x on the other side. So we are going to subtract the 3x. So that says negative 3x plus 4y is equal to negative 5. Now, once again, the A is a negative number, and we want it to be positive. So I'm going to divide everything by a negative 1, which basically changes the sign of everything. So that's a positive 3x, negative 4y is equal to a positive 5. And yes, this is a linear equation where A is 3, B is negative 4, and C is 5. I forgot to identify that in example G. A is positive 1, B is negative 2, and C is negative 5. Plot, label, and state the quadrant or axis that the point lies on. Okay, let me just talk about this. This is your x-axis. This is your y-axis. When you draw a coordinate plane with a straight edge, your ID is a perfect straight edge. You must do this on graph paper. Always label your x and y axis. When you go to plot a point, you start at the origin and you go, if it's positive, you go to the right. If it is negative, you go to the left. Then your y point, you go up if it's positive, down if it's negative. So when you go to plot a point. So let's plot point A. So you start at the origin and you go over 3, up 4. And that is point A. Now if you'll notice, there are four sections. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Now, I want you to turn off the recording, plot all of these points, and then turn it on to make sure that you've plotted correctly. Okay, so there's all the points. Now let's talk about what quadrant each one is in. Point A is in quadrant 1. Point B is in quadrant 2. Point 3 is not in any quadrant. It is on the x-axis. D is not in a quadrant. It is on the y-axis. E is in quadrant 3. F is in quadrant 4. And by the way, quadrants are always in Roman numeral. G is on the x-axis. And H is on the y-axis. A linear equation can be graphed on a coordinate plane. The x-coordinate of the point at which the graph of the equation crosses the x-axis is called the x-intercept. The y-coordinate of the point at which the graph crosses the y-axis is called the y-intercept. Pause this recording to copy these two sentences down in your notes. So looking at this graph, the x-intercept is the point right here. That ordered pair is -4, 0. You must always give your intercepts in an ordered pair. Ordered pair is x, y. The y-intercept is where it crosses the y-axis, and that is right here. That is the ordered pair 0, 2. So anytime you have to identify the x-intercept and the y-intercept, you must give it to me in an ordered pair. The book might say something like the y-intercept is 6. Well, you right away write it as an ordered pair. Just get in that habit right away to do that. Example 2a, find the x and y intercepts of the line. So you can tell by looking at this coordinate plane, this is your x-axis, this is your y-axis. The x-intercept is right here. That is the ordered pair 20, 0 is the x-intercept. Then we have the y-intercept, which is 0, 25. That is the y-intercept. The x-intercept on this graph, if you can see that here's the x-axis, this line does not cross the x-axis anywhere. So there is no x-intercept. And the y-intercept is the point right here, which is 0, 150. And you can abbreviate for INT for intercept. Example 4a. Graph 2x plus 4y is equal to 16 by using the x and y intercepts. Alright. To find the x-intercept, let y equals 0 and solve for x. So, that's 2x plus 4y is equal to 16. It says let y equal 0, so that's 2x plus 4 times 0 is equal to 16. 4 times 0 is 0. So that's 2x is equal to 16. Divide by 2. X is equal to 8. You must give me it in ordered pair. 8. What is y? 0. Then, to find the y-intercept, I'm going to abbreviate. Let x equal 0 and solve for y. So that's 2 times 0 plus 4y is equal to 16. That's 4y is equal to 16. Divide by 4, so y is equal to 4. And that is the ordered pair 0, 4. So when we go to graph it, again, make a coordinate plane. Label the x and y axis. You must label the x and y axis. And when you go to draw on your graph, when you go to draw the x and the y intercepts, notice that they have arrows at the end. Do you notice on my coordinate plane they have an arrow here, an arrow here? So make sure you do that. Now let's plot 8, 0 right here, and 0, 4 is right here. Draw a line. I didn't do a very good job here. Now make sure that you use a straight edge to draw your lines, no crooked lines, and put arrows at the end. Make sure your line goes past the points and draw your line. Example 3b, negative x plus 2y equals 3 by using the x and y intercepts. Another little shortcut you could do instead of doing what I did a minute ago, you could make a little table where you give x0, find y. So that would be negative 0 plus 2y is equal to 3, which is just 0. So that's 2y is equal to 3. Divide by 2. And that we have to turn into a mixed number, 1.5, because 3/2 is 1.5. We have to turn into a mixed number when you're graphing. So that's 1.5. And then give y 0 and find x. So 2 times 0 is 0, so that's negative x is equal to 3. Divide by a negative, so x is equal to a negative 3. Now, when you set it up in a table like this, it is already in an ordered pair. So that's kind of easy. It's a little bit of a shortcut. Okay, now again, we need to graph. We make our coordinate plane. Draw your x and y axis. Make sure you label. I will take off points if you do not label your x and y axis. We're going to plot 0, 1.5. So we're counting by 1, so 1.5 is about right there. The negative 3, 0 is right here. Draw your line, and again, make sure your line goes past the points and put arrows at the end. Use a straight edge. If you don't want to get a ruler, your ID is the perfect straight edge. For C, y equals negative x minus 5 using the x and y intercepts. Again, I'm going to do the table. I'm going to give x 0, find y, and then give y 0, find x. That to me is the easiest. So y is equal to negative 0 minus 5. Well, there's no such thing as negative 0, so we just say 0. So that's y is equal to negative 5. And then plug in 0. So y is equal to, we're going to plug in 0 for y. So that 0 is equal to negative x minus 5. You can do one of two things. We can add 5 to get x by itself. So that's 5 is equal to negative x, which divide everything by negative 1. So that's negative 5 is equal to x. So there we put in our table. And negative 5, 0. Again, draw your line. Make sure you label your x and y axis. Draw your line past the points. Oh, I didn't do a very good job here. I'll try that again. Example 5a. Graph 3x plus y is equal to 5 by solving for y and making a table. Now a table, you could call that an input, output table, or you can just call it a table where we have to solve for y first. So that means we have to get y by itself. We need to move the 3x on the other side. To do that, y equals now 5 minus 3x is not 2x. This is a variable, this is a constant. You can either write it 5 minus 3x, or you can write negative 3x plus 5. I always want you to write your variable first. So I want you to write negative 3x plus 5. I will explain at a later date why, but always put your variable in front of your constant. Now to make a table, make your columns. Now, just to be consistent, you can plug in anything you want for x. But to be consistent, we're going to plug in negative 2, negative 1, 0, 1, and 2. So that's negative 3 times negative 2 plus 5. Simplify using the order of operations. Negative 3 times a negative 2 is a positive 6, plus 5 is 11. Now let's plug in negative 1, so that's negative 3 times a negative 1 plus 5. Negative 3 times a negative 1 is a positive 3, plus 5 is 8. Negative 3 times 0 is 0, plus 5 is 5. Negative 3 times 1 is negative 3, plus 5 is a positive 2. Negative 3 times 2 is a negative 6, plus 5 is negative 1. So now we make our coordinate plane. Once again, draw your x and y axis, put arrows at the end, label your x and y axis. Now plot these points. Now if you're doing this on graph paper, chances are the negative 2, 11 would not fit on your coordinate plane. And if you can't plot it, that's okay. My graphs that I supply are a 10 by 10. Negative 2, 11 would be off the graph, so I'm not going to plot that point. I'm going to plot negative 1, 8, 0, 5, 1, 2, and 2, negative 1. Again, draw your line past your points and put arrows past the point. Put the arrows at the end. Example 5. I'm going to solve for y, so I'm going to subtract 2x. So that's y is equal to negative 2x plus 3. Make your table. Again, I'm going to plug in negative 2, negative 1, 0, 1, and 2. Again, you can plug in anything you want for x, but these are the easiest numbers. Negative 2 times negative 2 is a positive 4, plus 3 is 7. Now, what I want you to do is pause the recording, you finish this table, and then turn it back on and see if you get the same thing. Okay, so check your table and see if it looks like mine. When you plot the points, it's going to give you a straight line. If for some reason you don't have all of your points do not make a straight line, you know you've done something wrong. So there is your line.